Assalamualaikum. My name is Alia Bahira binti Izani from class 134.
My name is Nur Ayu Sofia binti Muhammad Khairi. I'm from 134.
I am Nur Aklima binti Abdurrani. I'm from class 134.
Assalamualaikum and very good morning to everyone. Today we would like to share with you about trigonometry function as we choose it as our topic for our group discussion for mathematics. Let's begin. Our today's agenda is first we want to tell you about introduction, and then we want to discuss about identity of trigonometry and its applications of trigonometry, and also the last one we want to make some summary. Trigonometry can be defined as calculation with triangles involved with the study of lengths, heights, and angles. Trigonometry and its functions have an enormous number of uses in our daily life. The trigonometric function can also be defined in terms of particular ratios of sides of right triangles. Here are the sine, cosine, and tangent functions. As we see in a triangle, we can put hypotenuse, adjacent, and opposite to represent the angle. We can find the length using the sine, cosine, and tangent function formulas. So we can memorize it as SOHCAHTOA. For instance, trigonometry is used in geography to measure the distance between landmarks. In yearly application of trigonometry, we can use it in finding the height of a mountain or hill. We also can constructing sundials to estimate the time from the sun shadow and finding the distance to the moon. While in astronomy, we can using trigonometry to measure the distance of nearby stars and planets, and we can also use it in the satellite navigation system. Apart from astronomy and geography, trigonometry is applicable in various fields like satellite navigation, developing computer music, chemistry number theory, medical imaging, electronics, electrical engineering, civil engineering, architecture, mechanical engineering, oceanography, seismology, phonetics, image compression, and games development. Okay, we move to the next part.
Most of us have learned basic trigonometry pretty early on, so by now we should already be familiar with the basic trigos such as sine x and cos x, and of course tangent x, which is equal to sine x divided by cos x. These should be very familiar to us, and later on we learn about cosecant x, secant x, and cot tangent x, which is equals to the reciprocal of sine, cos, and tangent respectively. Before we apply trigonometry into the real world, we must first understand their identities and relationships with one another. So, for example of trigo identities that we learn, we have sine square x plus cos square x equals to 1, sine a plus minus b equals to sine a, cos b plus minus sine b cos a. And for the last example, we have sine 2a equals 2 sine a cos a. These are just a few examples of the many trigonometry identities we learn. Now, let us try to validate and prove the trigonometric identities. Let's start with proving and validating the Pythagorean trigo identities. We learned 3 different Pythagorean trigo identities, which are the following. But for today, I'll be focusing on proving and validating sine square x plus cos square x equals to 1. So let us start with drawing a right angle triangle where base angle x has a opposite length that we will label as A, hypotenuse that we will label as C, and adjacent that we will label as B. From here, we can get sine x is equals to A over C and cos x is equals to B over C. Using Pythagoras theory, we can obtain a squared plus b squared is equals to c squared. Now, if we were to sine square x and add it with cos square x, we will get a over c squared plus b over c squared, which will ultimately give us a value of a squared plus b squared divided by c squared. From the Pythagoras theory, we know that a squared plus b squared is equals to c squared, so it will be c squared divided by c squared, which is equals to 1. And from here, we've managed to prove that sine square x plus cos square x is equals to 1. Now, let us take a look to observe and prove the relationships between different trigonometric identities with one another. For this example, I will be using the sum and difference identity where sine A plus minus B is equal to sine A cos B plus minus sine B cos A. And I'll be using the double angle formula where sine 2A equals to 2 sine A cos A. Now let us use sine A plus B equals to sine A cos B plus sine B cos A. Let us use b equals to a. Then we will get sine a plus a equals to sine a cos a plus sine a cos a. And from there, we can obtain sine 2a equals to 2 sine a cos a. And just like that, we managed to validate the trigonometric identities.
So we will continue our discussion about the application of trigonometry in real life. Trigonometry may not have its direct application in solving practical issues in many cases, but it is applied in various things in our daily life indirectly. Trigonometry spreads its application into various fields, and one of them is architecture. Architects and people working in construction use trigonometry in a number of different ways. It's used to work out the height and the basic structure of a building. An architect can use the functions to calculate loads and forces of a building. Without these calculations, building will not be safe. Trigonometry also used in the construction of a building. The correct slope of a roof and the proper height and rise of a stairway can both be calculated with this mathematical technique. Trigonometry also plays a major role in musical theory and production. Sound waves travel in a repeating wave pattern which can be represented graphically by sine and cosine functions. A single note can be modeled on a sine curve, and a chord can be modeled with multiple sine curves used in conjunction with one another. A graphical representation of music allows computers to create and understand sounds. It also allows sound engineers to visualize sound waves so that they can adjust volume, pitch, and other elements to create the desired sound effects. Trigonometry plays an important role in speaker placement as well, since the angles of sound waves hitting the ears can influence the sound quality. Trigonometry is just as useful in the field of criminal justice as it would be to an architect. In criminology, trigonometry can help to calculate a projectile's trajectory, to estimate what might have caused a collision in a car accident, or how did an object fall down from somewhere, or in which angle was a bullet shot. Blood stain pattern analysis (BPA) is a valid forensic method which belongs to the category of biological methods using trigonometric models. Despite its development through the years, the method has been reformulated, a standard one and globally used, recognized in standard sheets. This method permits exact analysis of the dynamic and characteristic properties of bloodstain after impact on surfaces such as floors, walls, and ceilings. various exterior and interior items encloses, it is also possible to determine the characteristics of blood from the outer part of the body. According to the presence of blood and its quantity, it's also possible to use this method for verification of reconstruction of criminal acts while being tested for its validity with primary conditions of preserved and readable traces of. The last example is in navigation. Trigonometry is used to set directions such as north, south, east, west. It tells you what direction to take with the compass to get on a straight direction. It is used in navigation in order to pinpoint a location. It is also used to find the distance of the shore from a point in the sea. It is also used to see the horizon. In GPS systems, triangulation used to find and fix positions, extrapolating what is unknown from what is known. Triangulation is also used to measure the distance between Earth and distant stars and galaxies, thus aiding future space travel.